Hello friends, today I'll solve the LeetCode daily challenge called merge nodes in between zeros. So we are given a head of a linked list which contains series of integers separated by zeros. The beginning and end of the linked list will have node.value equal to 0. So for every two consecutive zeros, we need to merge all the nodes lying in between them into a single node whose value is sum of all the merged nodes. And the modified list should not contain any zeros. We need to return the head of the modified linked list. So let's consider the first example. So we are given a linked list where we have some nodes with values 0 and between two consecutive nodes having value 0, we have some nodes having non-zero values. So we need to merge them. So in the first example, you can see we have three nodes with value 0. So we need to merge the nodes with values 3 and 1. So the merged node becomes the node with value 4. Similarly, we need to merge these three nodes, that is the node with value 4, 5 and 2. These three will be replaced by a merged node with value 4 plus 5 plus 2, that is 11. So the output will be two nodes with value 4 and 11. Similarly, in the second example, we have four nodes with value 0. So the output will contain three nodes. So between the first two nodes with value 0, we have a non-zero node with value 1. So it will be as it is in the output. Similarly, between the second and third 0, we have a node with value 3. So it will be in the output as it is. And between third and fourth 0, we have two nodes with values 2 each. So the output will contain a node with value 2 plus 2, that is 4. So we are given that there are no two consecutive nodes with value 0. So it means between two nodes with value 0, there will be at least one node with non-zero value. And we are also given the beginning and end of the linked list will always have value equal to 0. So the idea is we will linearly traverse the linked list, and between every two consecutive zeros, we will accumulate or we will sum the values of all the non-zero nodes, and we will store that sum in a node. So let's try run for the above idea for the given examples. So I have taken the first example. So I am declaring two variables called and another variable called tail. So initially they will be pointed to the second node, that is the node after the first 0. I'll increment current while current.value not becomes 0, and I'll accumulate the sum. So here the current value is not 0, so I'll increment the sum to 3 and I'll update the current. So here the value is not 0. I'll add it to the sum, then the sum becomes 4. Now I'll come here. The value of current is 0. So I'll increment the current to next node. So the current is here. Now I will update the current value of tail to sum, that is to 4, and I'll update the next value of tail to the current, and I'll update the tail. Now the tail comes here. So now we have a node with value 4 in the output. Again I will initialize sum equal to 0. I will linearly traverse while current dot value is not equal to 0. So here current is 4, so I will update the sum to 4. Next I will increment the current. Here the value is 5, so I will add it to the current sum, so it becomes 9. Then I will increment current. I will add the value to the sum, so the value becomes 11. Then I will increment current. So here the current value is 0, so again I will increment. Now the current becomes null, so I will update the value of tail node, that is it will be updated to 11. Then I will update the tail to current, that is equal to null. Then I will assign the tail to current. So basically these are the three steps I am doing. First I am updating the value of tail to sum, then tail dot next becomes current, then I am assigning tail to current. So now tail will be pointing here. Now the node with value 11 becomes part of the output, and we can see the current becomes null, so we will stop here. Then I'll return the address of this node. If we are given the head node's address, so it will be head.next. So the output will contain two nodes. As we are linearly traversing the array, so the time complexity will be big O of n, and we are just declaring few variables, and we are also using the input array to compute the output. So we can say the space will be big O of 1. Similarly, let's dry run for the second example. Initially, current and tail will point to the second node, and I'll initialize a variable sum equal to 0. We can see the current value is not equal to 0, so I'll update the sum. So sum becomes 0 plus 1, that is 1. Then I'll increment the current. The current value becomes 0, so I'll increment again current. So now I'll perform these three steps. I'll update the tail value to sum. Then I'll increment the next pointer of tail to current, and I'll update the tail to current. Now tail comes here. So in the output we'll have a node with value 1. Then I'll again initialize sum equal to 0. Then I'll linearly traverse. The current value is not 0, so I'll add its value to the current sum. The sum becomes 3. I'll increment current, and you can see the value of current is 0, so I'll again increment it. Now I will again perform these three steps. I'll update the value at tail node to sum, that is 3. Then I'll update the next of tail node to current, and I'll update the tail to current. So in the output we have another node with value 3. Again I'll initialize the sum variable to 0. The value at current node is non-zero, so I will add it to the current sum. The value becomes 2. Then I'll increment the current. The value is non-zero, so again I will add it to the current sum. The value becomes 4. Then I'll go to next node. The value is 0. Then I'll increment the current. Now the current becomes null. So again I'll perform these three steps. I'll update the tail value to sum, that is 4. Then I'll assign tail.next to current, so it becomes null now. Then I'll update the tail to current. So in the output we have another node with value 4. So now the current is null, so I'll stop, and I will return the address of second node. That is, if this is head, then the address of second node will be head.next. So at the end I'll return head.next. So now I will code the solution. So first I am declaring two variables, current, that is equal to head.next, and I am declaring another variable called tail, that is also equal to head.next. So while current not equal to null, I'll initialize a variable called sum. So while current dot value not equal to 0, I will add its value to the current sum, that is sum plus equal to current dot value, and I will update the current to next node, that is current equal to current dot next. So now the current points to a node with value 0, so I will update the current to next node, that is current equal to current dot next. So now I'll update the value of tail node, that is tail dot value becomes sum. Then I'll update the next of tail node, tail.next equal to current, and I'll update the tail node to current. At the end, I'll return the address of second node, that is head.next. So let's run it for the sample test cases. Sample test cases are running fine. Now I'll submit it. So it's working as expected. So I have attached the GitHub link for this solution in the comment. Please do check it out. If you have any suggestion or comment, please post it in the comment section. I will be happy to help. If you like this video, please subscribe. Thank you.